It's easy in theory to prove contribution, but in systems, it's very hard, and it has been hard for me also. Recently, I learned something new, and I applied on one paper, and it worked. So I wanted to share with you. It's just my opinion. You can try it if it works for you. So uh, let's visualize when we think about systems research, it's like we vision about some system. So I thought about two systems. For example, a context-aware dishwasher. So it detects the dishes, like they are plastic or they are ceramic or they are metal, and accordingly it controls the water flow and the spinning speed. So that's how it is context aware. Second example is context aware helmet. So you are wearing helmet, biking. It can control the volume, the openings, air. So if it's cold, it can close the opening so you don't get any air. So it's warm. If it's warm outside, it can open. So it's a context aware helmet. So I found these two topics. And I think musical helmet, context aware musical helmet, it's quite interesting. It's a new idea. And my master's is done. So that is the feeling I get, that I am building a new system. So what I have to do is find some tools, find go through some languages and some Stack Overflow, some bugs, debug my code, implement this, and done. I have built a new system. I don't have to worry about evaluation. My scientific contribution is clear. So that, in my opinion, it's a myth. It's my personal opinion. I don't believe just building something new is going to be a scientific contribution. It's maybe you're just lucky. You found something new. So this is the first message of my presentation. So if this is not a contribution, shall we not work on new ideas? No, we still work on innovative ideas, but that is just beginning. That's like a research topic. So you pick that research topic and you identify the blocks. So if you go in the dishwasher example, we have to identify dishes first. Then we have to determine what is the right spin and flow for each kind of dish, and then we take some actions. Similarly, for the helmet application, we detect the context. Context means temperature, maybe some physiological signs. Again, determine what sound is good for what temperature and what outside noise, and the airflow, depending on the temperature outside. If it is cold, you block the airflow.
Is it cool?
Huh?
Is it cool? It's a right way we should do.
So yeah, you identify the blocks of the system.
This is the steps we have to take.
Yes.
This is his suggestion.
My suggestion. Yeah. So like you have this big research topic, you found the application, and you divide that into blocks. You identify what we call it building blocks. What blocks build that application? After that, you pick block by block and look into the literature. Can we implement this block using some techniques in the literature? Most of the times you find something related. So you take that related method, but probably because this is a new application, you have some new constraints. So you take that application, put into your system, measure something. Then you customize it, you improve something using the tools and techniques, statistical tools, mathematical tools, learnings, and optimize that existing method for your application, your system. Then you again measure the performance, you compare. That's the easiest way. You compare, you have the results to prove your contribution, that you have done something better. Now the problem is that most of us we have is, what if we don't find any previous work? And that's the tricky part. That's where we have biggest trouble. When we don't have previous work, we tend to believe that, okay, I'm done. There are no previous works. I have seen in many presentations, I could compare, but there were no previous works. And I thought a lot about this, and recently I I could solve this puzzle only recently, that even if you don't have any previous work, you still have to find a baseline method that a simple programmer who is not master's research student, who is not PhD, who doesn't have research attitude, how will that person implement your application? You implement that application, that's your baseline. You'll always find baseline. You can't have any excuse for baseline. You take the baseline, and starting from this baseline, carefully think about some aspect that you can improve using some algorithms, some learning, again the same thing which we used to do with the previous works. Improve that, and then you show these results. So even though there is no previous work, you still have to evaluate. So the conclusion is, a common person could do it, a programmer could implement it, but because you are a master student, you did it in a smarter way. You had the attitude to do research, so you look at different options, different methods. Probably you evaluate different learning techniques here, and then you say, this one is the best. I could find out because I have this knowledge which I used, and it's not just implementation. So to make it more clear, let's go back to our examples. So this is baseline. If I see this is, although there are no previous works on identifying disease, I use the weight, just weight. Plastic is very light, glass is little heavier, metal is very heavy. I use 3 thresholds, I divide, I detect. That is my baseline. For the music, I use sensors to capture the environment, temperature, everything. That becomes baseline for the musical helmet. Now I go ahead, and what I do, for the discs, when you put discs, they make noise. And the noise gives an indication of what kind of disc it is. So I also capture the sound and use sound and weight fusion to detect the discs. I do it better. I measure the accuracy and I report that result. That becomes my contribution of this work, which is context-aware dishwasher. If we detect the context, so if you look at the previous slide, in musical helmet, I use the current sensor measure. But when you change the volume, you are changing for the future, not for the current time. So what you do, you build a model. You see that the temperature changes in this way, or the weather changes in this way. You predict for next 5 minutes using that model, and you use those values, not the current value, the predicted values, to adjust your volume and the airflow. So your baseline, then in experiments you compare that. If we don't use our model, this is the baseline, we can still implement, we are able to implement, but it's okay, any programmer can do it. But because we are master students, we did research and we found out if we use this model, we can predict it better, it is more accurate, it's more enjoyable, because we are learning and we are doing it better in some sense. So the tricky part where you have to spend time is to find the right performance measure also. So for your application, have very, very clear that what are the performance measures, what are the things which you really want. That will help you find out the improvements over the baseline. And the last point is, if you are not able to identify those abstract blocks, you can always go deeper. Deeper you go, you find more problems. So generally in every research there are a lot of problems. We just overlook them. So I'll just summarize the steps. You identify, after you decide your application topic, like context-aware musical helmet, you identify the building blocks of that system. For each block, look for the previous works, previous methods. You find any, tag them, improve them, report in your thesis. If you don't find anything, then choose a baseline like your raw implementation, and then look at different components, what you can improve them, compare them, and report in your paper or thesis. Thank you.